Hi there. In today's video, we are looking at question 5, which is a trigonometric question from the November 2024 paper 2 exam. Okay, so starting with 5.1, we are told in the diagram, line OP, which is this one, is given with point P, and we are looking at KOP, which is we're going to call angle A. In 5.1, they want us to determine without using a calculator, meaning we have to rely on this diagram to calculate cos A. So cos is adjacent over hypotenuse, so that means we need to determine all the sides of this diagram before we can proceed. So joining our dots, this will be our triangle. This is X and this is Y, and this will be our R. So we need to determine what all of that will be. Now, because we have the point P, we already know that X will be -3 and Y will be -4. Because we've been given coordinate P. Now all we need to do is to determine R. So 5.1, R will be equal to, so we're going to use the distance formula, or we can also just use Pythagoras. I think it's easier to work with Pythagoras since we have X and Y. So it would be the square root of -3 x squared plus -4 x squared. 3 is 9, 4 is 16, meaning that R is going to be square root of 25, which is just 5. So here we can write that our R is 5. Okay, now we can actually start with 5.1.1. Cos A it's adjacent, which is X over our R, our hypotenuse, and X is -3, hypotenuse is +5. And that's the solution for 5.1.1. 5.1.2, they want cos 2A. Cos 2A. Now you should recognize this as a double angle identity, and it's the cos one, so you've got 3 options. I'm just going to choose 2 cos squared A minus 1. But whichever solution you choose for this identity will work out fine. Okay, so we already have cos, it's -3 over 5, and then we square it, minus 1. This is going to be 9 over 25, multiplied by 2, and then we subtract 1. Putting this in a calculator, you end up with -7 actually over 25. That's our solution. Okay, 5.1.3, we need to calculate sine A minus B. If we're given sine B and we're given the restrictions for B, it's between 90 degrees and 360. Okay, so B, we are having to figure out which quadrant it is in. Now we can see it's sine B and it's positive, so basically we need a quadrant between 90 degrees and 360 where sine is positive. And sine is only positive in the first 2 quadrants, which is quadrant 1 and quadrant 2. So that means our only option is that B is going to be in this quadrant 2. Okay, so let me erase this and then I can do a little sketch for where we can expect B to be. So B is going to be somewhere there like that. and 4, oh, this is actually the angle. This is now B, and the coordinates are, so sine B is your opposite over hypotenuse, which is, so sine B, it's y over r. So for us, it means we've got the y value and the r. R is also 5, and then the y, so let me draw the dotted line for our triangle. Rectangle. Yeah, for our triangle, and this will be 4. And we just need the x value. And with our knowledge, it appears that the x will be 3. -3, since we are in the second quadrant. So 5.1.3, the x will be -3, because it's the same triangle as the one we have at the bottom. It's just that the one in quadrant 3 has been flipped over. Okay, now we can proceed with our calculation of sine A minus sine B. Sine A minus B. And this will be equal to, so this is a compound angle identity, which gives us sine A cos B minus cos A sine B. Okay, so now we just need sine A and to substitute also for cos B. And we already have sine A. No, we don't. We can calculate it. So sine A would be opposite over hypotenuse, which is -4 over 5. And then cos B will be adjacent, so that would be -3 over 5. And then cos A we had as -3 over 5. And then sine B, I remember it was +4 over 5. Okay, now it's just time to multiply everything out. So 5 times 5 is 25 in the denominator, and then 4 times 3 is 12, and it's positive, minus 25. This one's going to remain negative, so I need a bracket around it, and it's -12. So essentially, we just have 12 plus 12. 24 over 25. And that is our final answer for 5.1.3. Okay, moving on to the very, very last question, 5.2. We are told if cos alpha is equal to P, we need to express the following expression in terms of P. Okay, so let's write this. So we've got alpha over 2 minus 45 occurring in both trig ratios. Why am I writing sine? 5.1. Oh, it's 5.3. Okay, so sine alpha over 2 minus 45 cos alpha over 2 minus 45, and everything divided by 2. Okay, so whenever you see sine and cos and they have the same angle inside their brackets, this hints towards the double angle identity for sine, because we know sine 2 theta will be equal to 2 sine theta cos theta. So we can use this to our advantage and manipulate this expression so that it ends up looking like this. So how we're going to do that is we're going to multiply by 2 in the numerator and denominator, because that is actually equivalent to just multiplying by 1. So we're going to multiply everything by 2 over 2. So we're not breaking any rules of maths. So what we end up with now is 2 sine alpha over 2 minus 45 cos alpha over 2 minus 45. And then now in the denominator, we've got 2 and 2. Okay, so now that it is in this form, we can apply our double angle identity for sine, which leaves us with sine, open bracket, 2 times, open another bracket, alpha over 2 minus 45 degrees. And everything is divided by 4 because that's 2 by 2. Okay, so now what we can do is we can multiply this 2 to everything inside the bracket, leaving us with sine 2 over 2, that's cancels out. So now we're just left with alpha minus 2 times 45 is 90. And here we still have the 4. So now we've got alpha minus 90, which looks like a co-ratio, but we can simplify it. So this can be sine, we take out a negative, and then we write the 90 first. So once we take out the negative for 90, it becomes positive, and for alpha it becomes negative, like that. So now it's something we can recognize, and this is 90 degrees minus alpha. When we apply co-ratios, it then becomes cos. But because there's this negative inside over here, we are basically looking at negative angles. And we know sine is negative in the 4th quadrant. So then it leaves us with negative cos alpha over 4. We are actually almost there, because in our question we are told cos alpha is equal to p. So our final answer will be negative p over 4. And that's it.